This is what you will be able to achieve in just a few minutes if you watch this tutorial. As you can see, I have two browser windows. They have different MetaMask accounts associated with them that I've logged in with. And as you can see, if I move this guy here on the left, in the left window, he moves in the right window. If I go to the other window, now I'm playing this, I move this guy, as you can see, he moves and follows along just fine. Now, it's 10 lines of code. I mean, this extra logic is 10 lines of code. So guys, hope you like, smash the like now, and let's begin. Alright guys, welcome back. In this video, we will be continuing our game development, and as you remember, we left off right here, where we have our guy, and we can move him around, we can jump, and so on and so forth. If you haven't watched the first video in this series, you should go back and watch this one, building NFT game from scratch. And as you know, the reason why we're building this is because we're preparing for the Aavegotchi game jam, which is happening on September the 1st until September the 5th, where you have to build a game where users log in, they can use Aavegotchi, they can move around, they can play, they can have high score, stuff like that, and you can win $6,000. We're also sponsoring this event, just so you know. So use the link below, sign up. And so in the first tutorial, I showed you how to do the simple game that we have right now. It's single player, we can move around, we can jump. In this video, I will show you how to have multiplayer, basically have to have several different clients connect to the game, and where each client gets a character. And when we move around, all clients show all the characters in real time. And then in the third episode after this one, we're gonna have Aavegotchi integration, where I show you how you can log in and you can select Aavegotchi and you can play around with it. And then it's up to you to think of some kind of game to create with this tech that we've been showing you. So the first thing I'll add here is this notion of player position. As you can see, I create this object right here, player position, which is an instance of Moralis object extension of player position. And you remember that when we do like this, we create a new class in the database if it doesn't exist. Then I set the player XY, and I ensure to set player last X and last Y, so that we only run this saving to the database if the player position has actually changed, because we don't want to be writing the same numbers over and over again. So if we're just idle, like right now, the screen is idle, player does not move, there's no need to push this information to the database, because database already knows where the player is. That's why we check it beforehand, and only then do we move the player if the player actually moved somewhere. So if I move around here like this, and then if I go back to my database and I refresh, as you can see, we have some entries here in the database with all of the positions of this player. And as you can see, if I refresh now, nothing, is still only 34. If I go here, I go back, still only 34. So I need to move for this to go up, all right? And if I go back now, as you can see, it's 257, so it grows quite quickly. This table will grow very, very quickly. And so, of course, this will become pretty huge. But at the same time, all of this old data is irrelevant. I mean, it can be used in order to replay the movement of the player, but nobody needs that, at least for our purpose. So, at the end of this tutorial, if we have time, we can add to the cloud function, to the trigger. As you know, in database we have so-called triggers that we can put in the cloud code, so that when we save a new player position to the database, we can have this trigger after save, and here we can check how many entries we have in the database, and we can remove old entries. So this way we always keep only the recent positions. But for now, let's clean this. We'll clean manually for now. Player position. And so the good thing is that in Moralis, you can use live queries in order to subscribe to new events. So if you go to database, you go to live query, everyone now can subscribe to this these updates. So if we go to create here, we can set up a subscription to player location. And when we get a new entry into player location, for example, here create, we can check so that the user that just moved is not our user, because we don't need to update our own location. We know our own location. But we can check so that, let's actually see p location. We can check so that if p location dot get player is not equal to user dot get eth address. So if this is true, we can write someone moved, and then we can also say who moved, and the person that moved is plocation dot get player, and we can say new x position, and here we take plocation x, and likewise we do new y plocation get y, like so. Now if I run this game right now, like so, we have a problem. Why? Because we use await, and create is not asynchronous. So let's fix that. So if I run this and I move, you see nothing happens. Why? Because we move our own current player, and we check, here we check, so that the player that moved is not our own player, because we know the location of our player. Instead, let me load a new game right here, and let me log out, and let me log in here again. Let's see. Yes. So I have now this window, and I have this window. So I have two windows, and they're logged in with different addresses. As you can see, this one is logged in with 0x4. This one is logged in with 0x5. So what happens if I move? What happens? One second. Let me reorganize here a bit, like so. Okay. I move this guy to the left. Nothing happens. Let's see. Let's see, player location, that's correct. So now we have to do some debugging, like always. You see, it's player position. Player position, sorry. All right, so let's go back here. Let's refresh this. Let's refresh this. Yes. You see, he fell down, and already we get updates here. So if I move this guy to the left, you see this guy gets updates that someone moved. Who moved? This guy moved. And this is my wallet right here in this first window, 5E. If I move this guy now, oh yeah, this is the same. If I move this guy on the left, you see that now we get updates here about the position. So what do we do? Now that we have this position, we can move the players on the screen, but we don't have them on the screen right now. So how do we draw them? Well, we can create player. Well, we need to, we can have player, and then we can have, so player is the person that is playing right now, but let's also have competitors. Competitor. So competitors are the other players that are not us. And of course, you can design this in different ways, but this is how I'm gonna do this now. So when we get a new location, we have to first see, does this address, have we seen this address before? Because if we see this address, we put it in competitors. But right now, I'm checking if competitors has never seen this, and competitors, by the way, is an object. So I define it as an object. And so if competitors does not have a value for this key, and the key is the player address that just moved somewhere on someone's computers, so the first thing we have to do is to define the image. So if first time seeing. So if first time seeing, we have to draw on, or we actually need to create a sprite like this. So how do we create a sprite? Very simple. We don't want to do exactly like here, because here we use physics and stuff. And let's see, should we have physics here? Collider, this physics, refresh. I'm not sure we should have physics at all here, because physics of this game should not... Let me think. In this case, let's experiment. Let's first not put any physics. So let me go back to phaser. So I will not put any physics actually here. Because physics should not affect this guy. Player. Set scale 0.3. The physics of this game should only affect the player of this game, and the physics of the competitors, they will be handled by the client of the competitors. This is not how we would build it if we would be building a real game, because then the server needs to handle all physics, but that's a lot more complicated. And so for this simple demonstration, let's see how this is. This could work, or maybe this will not work. Let's see. I open this here, and I open this here. Let's see. So I add image player, but it's not showing. Interesting. P location X. Let's see what happens if I add him here. It's not showing for some reason. Okay, let's see what happens if we add like last time. I put so, and I put so. So now I'm actually using physics, but I'm not sure this is correct decision because, the physics of this game should not handle the other players. But yeah, it's also not showing. That's interesting. Oh, guys. Big mistake. Let me actually go back. So I go back to the version without physics, like I was thinking. So, of course, we do this when we've never seen the player, when the data structure is empty. That's when we show. Yeah, see? we have the guy. We're drawing another guy, but we're drawing them in the wrong location because they should be drawn like so. Yeah, see, we're getting close, guys. Refresh, refresh. Let's see. Yeah, see, at least now the starting point is correct. So if we haven't seen them, we draw them there. And if we've seen them, then it's even easier, because always in game development, you will have hiccups, like we just had one, you know, where we couldn't figure out why it was not drawing, and then it's a simple if statement that was defined incorrectly. That always happens. All right. So if we've never seen them, yeah, there you go. Go here. Up, 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 up. Oh, you don't see both. 1 second. Check. Whoop, whoop, whoop. There is some lag. And I will soon explain to you how to remove the lag if you want, if you need that. Voila. Okay, let me tell you how to remove lag. Because look, there is always gonna be some lag. You know why? Because it's going through a server. And we have the physical realities of the physical world, because when something needs to go through a server before it gets back to you, it's not gonna be that, it's never gonna be smooth. Never gonna be smooth. Instead, there are many different techniques. I recommend, if you really like game development and you want to be good at this, you should be reading this blog post, Fast-Paced Multiplayer, where it says that all multiplayer games, they have to have a server that ensures that you don't cheat. And this means that all data needs to go through a server first. But when you go through a server, you will have lag, you will have latency. And there are a few different scenarios how to do this, how to decrease the lag, and you can read it in order to understand. But basically this means that you need to do some math on the client side. So, for example, when I move this guy here, I move him to the right or I move him to the left, you see that the lag in the other window, so in this case I'm playing with the guy on the left, and the guy on the right is trying to catch up. Well, the guy on the right doesn't have to wait for the server to tell it where the character is. This screen on the right can predict where the player is gonna move to. So right now we have two clients. We have client here and client here. And if I want to do something in this client, in this web window, the signal has to go first to the server, and then the server sends it to all other clients. In this case, we only have one client. But let's say this client right here moves his character to the right. And this client right here can say, I see that that this guy right here tries to move his character to the right. Let me assume that he will keep moving, and I will draw a smooth animation. I will draw a smooth animation of you moving to the right, and then I just wait for the server to confirm that I've predicted the movements correctly. Do you understand? So instead of waiting for the server to tell, okay, this is the position, this is the position, this is the position, this will always have lag if the server has to tell you this is the position, this is the position. Instead, you can predict. You can see, this player is moving in this direction. Probably he will continue to be moving for at least a few milliseconds. So let me keep drawing it smoothly. And then the server will most likely say, okay, this is the position, and the server is just moving in that direction. But you don't have to wait. You can already start animating towards that direction. Is this easy? No, it's quite complicated. That's why it's a bit outside of this scope, as this game works. I mean, it is good enough. All right, it's good enough for our demonstration, which we've done in like 20 minutes. Can this be better? Yes, we may create a series on where we or when we do this, lag compensation, and where we do these techniques. Let me know in the comment section if you want that. But for now, we do have this fantastic small game that we've written with very few lines of code. I mean, if you truly think about it, here we have very easy if statement, like 3 lines of code. And here we have an easy if statement. And that's all multiplayer. I mean, this is all we need for multiplayer. That's the power of Moralis. That's the ease of use of Moralis. That's the magic of Moralis. That is how you really gain the power of Moralis. You can build anything, man. It's so easy. I hope you like, guys. See you all in the next episode. And in the next episode, we will be focusing more on Aavegotchi, all right? We're gonna be actually using Aavegotchis, reading data from chain, reading SVGs, and so on and so forth. So hope you like, guys, and goodbye. Smash the like. By the way, go to the forum. If you need any help, you can just go to the forum here, and you can discuss anything. And we already had this discussion about lag in MMO and how to solve that. So you can ask more questions. Guys, hope to see you all very, very soon. Have a good day and goodbye. Goodbye, goodbye, goodbye.